Welcome to the course Introduction to Cognitive Processes. I am Ark Verma from IIT Kanpur, and we have been talking about aspects of reasoning and decision making in this lecture. Last lecture I talked to you about kinds of reasoning, inductive reasoning, deductive reasoning, and today I will talk about so I talked about deductive reasoning in the last lecture. Today we will talk about inductive reasoning and how do we reach to conclusions from particular kinds of evidences. We will also talk a little bit about how our making of conclusions from these evidences are affected by various biases that we succumb to at some point. So, in inductive reasoning, the premises are based upon the observations of one or more specific cases, and what we do is we generalize from our observation from these cases to get to a more general conclusion. Now, one of the things is that in inductive reasoning, these conclusions are that are just suggestive, they are not really very definitive. And these suggestions have various degrees of certainty. I can be 10% sure, 20% sure, 30% sure, or 70, 80 or 90% sure, but generally I am never 100% sure. So, this is one of the classical differences, major differences between inductive reasoning and deductive reasoning. Suppose I am reading out a couple of examples for you from Goldstein's book. Observation: all the crows I have seen in Pittsburgh are black. When I visited my brother in Washington DC, the crows that I saw there were black too. A good conclusion would be that I think it is a pretty good bet that all crows are black. So, this is again it is a guess. Another observation could be here in Tucson the sun has risen every morning. The conclusion could be that sun is going to rise in Tucson tomorrow. So, different degrees of confidence. In the last one, the degree of confidence is much more. We do not really look for validity when we are trying to engage with inductive reasoning. What we are actually looking for is how strong the evidence is, how strong the argument is, and strong arguments basically result in conclusions that are more likely than weaker arguments. We do not really talk about final conclusions or stuff. Now, the strength of these arguments can be basically determined by three things: representativeness of observations. So, if you are looking at an observation, how well does the observation about a particular category resemble or represent all members of that category? Also, a very important factor is number of observations. How many observations have you made? 1, 2, 20, 200, 2000, 20,000. Adding more and more observations basically makes the argument much stronger. If you remember the last example, here in Tucson, the sun has risen every morning. So, the confidence in the conclusion is a bit more as compared to the confidence in the earlier statement. And the third is the quality of evidence that you are looking at. The stronger evidence leads to stronger conclusions and more definitive, more let us say better conclusions. Now, let us talk a little bit about how our process of inductive reasoning is affected by a variety of biases and variety of things that come in. When you talk about availability heuristic, so when faced with a choice, when somebody is asked to make a choice, what we do is we are often guided by what we remember from our past, and the most recent past is remembered most more. So, the idea is the availability heuristic states that events that are more easily remembered, more especially events that have just occurred, are judged as being more probable than events that are less easily remembered. Okay, I will give you an example. When participants were asked to judge whether the whether there are more words with R in the first position versus more words with R in the third position, a lot of people basically responded that there are more words that begin with R. 70% participants responded that there are more words that begin with R compared to more words that have R in the third position. However, it is actually the case that there are much more words that have R in the third case in the third position as compared to words that begin with R, because it was easier to remember words that begin with R as compared to remember words that have R in the third position. People thought that much more words must begin with R. So, this is one of the examples or demonstration of availability. I will show you a table right now, which basically has likely causes of deaths, and people were asked to respond to them. You will see that as far as homicide is concerned, 20% homicides basically happen 20 times more than than appendicitis, and 91% picked the more likely cause of death as compared to appendicitis. But if you look at some of the other things, almost 83% of the people wrongly chose pregnancy as causing more deaths as compared to appendicitis. So, in this pair, so the idea is that what is happening here is a substantial proportion of participants are misjudging the relative likelihood of these causes of death. A large number of errors are basically associated with causes that has been publicized by media. For example, 58% of the people thought that there were more deaths caused by tornadoes than asthma, while in reality 20 times more people die of asthma than from tornadoes. But because tornadoes in the United States are more on the news, they are publicized, they are talked more, and they are, there are so many pictures and visuals available that a lot of people misjudge the fact that asthma basically leads to more deaths as compared to tornadoes. You can look at the fourth figure here. 42% of people are making the correct choice. Another example is that 41% people thought that participants thought that botulism causes more deaths than asthma. So, you see here asthma and botulism. So, 41% people are making the wrong judgment and selecting botulism over asthma. Now, an experiment was done by Stuart McKelvey in 1997, and that demonstrates the fact that availability heuristic, it kind of demonstrates it in a different way. So, what they did was McKelvey presented lists of 26 names to participants. There were two conditions. In the famous men condition, 12 of the names were famous men and 14 were non-famous women. While in the famous women condition, 12 of the names were famous women and 124 were and 14 were non-famous men. Okay, so 12 famous men, 14 non-famous women, 12 famous women, 14 non-famous men. When participants were asked to estimate whether there were more males or more females in the list they had heard, their answer was influenced by the fact that whether they had heard famous male or the famous female list. 77% of the participants who had heard the famous male list suggested that there were more males in the list, even though you see there were 14 non-famous women. And 81% of the participants who had heard the famous females list suggested that there were more females in the list. So, the result is consistent with the availability heuristic, because you hear more famous, you hear more of famous people. The idea is that is influencing your judgment of how many people were there in all. The next heuristic that affects our decision making is referred to as the representativeness heuristic. Now, the representativeness heuristic basically is based on the idea that people often make judgments based on how much one event resembles the other event. Suppose for example, you have observed one event and you kind of try and liken this event to all the other events. This has happened, this one it resembles what I saw last year, or this one resembles what I saw 2 days ago or 5 days ago or 5 years ago, and you kind of make this likeness. So, in other words, what is happening is that the probability that, for example, A is a member of class B can be determined by how well the properties of A resembles to what we associate with being the general properties of B. I will show you this with an example. So, randomly people picked one male from the population of United States, the male Robert, and he speaks quietly, and he wears glasses and he reads a lot. Now, then people were asked whether Robert could be a librarian or a farmer. So, you can guess it while I am going to the next slide. What do you think Robert basically does? When Tversky and Kahneman they presented this question in an experiment, more people judged that Robert was a librarian. Why? Because this is more associated to how we perceive librarians as. They were influenced by the representativeness heuristic into basing their judgment on how closely they think the characteristics of this male Robert resemble that of a typical librarian. So, what you are doing is you are likening these characteristics to what the stereotype of a librarian is. However, in doing so, they were ignoring a very important source of information, that the base rate of farmers and librarians. There are far more farmers in the country as compared to librarians. So, if somebody is randomly picking some male, there is a much higher chance of that person being a farmer as compared to a librarian. I am sure this kind of example would work very well in our country as well. So, this aspect of base rate, what is the base rate? Base rate is basically the relative proportion of different classes in the population. So, by that maybe Robert was more likely a farmer, because in 1972 at that time US had much more farmers than librarians. If I talk of India, obviously the thing applies here much more, that we probably have much more farmers than librarians in the country. So, what happens, suppose if you tell the base rates to people, if you inform them of the base rate while you are asking them to make these decisions. So, participants given this problem correctly guessed that there would be a 30% chance of picking up an engineer. However, for some participants another description was added. So, the similar task was there and they were basically given that the base rate is 30% of the chances that you will select an engineer. Some other, for a different group of participants, other information was also added. Now, adding this description caused participants to greatly increase their estimates that randomly picked person was engineer. So, what they are doing is they are including the base rate information in their judgment. Let's say this example, in a group of people there are 70 lawyers and 30 engineers. What is the chance that we pick one person from the group at random and that person will be an engineer? So, obviously 30% will be an engineer. Now, let us take a different example. Jack is a 45-year-old man. He is married and has 4 children. He is generally conservative, careful and ambitious. He shows no interest in political and social issues and spends most of his free time on his many hobbies, which include home carpentry, sailing and solving mathematical puzzles. Now, apparently when only base rate information is available, what people do is people use the base rate information, but when other descriptions are available, people disregard the base rate information, and this also can lead to potential errors in judgment, as you would see in the last example. So, what is happening is, another characteristic of this representativeness heuristic is the conjunction rule. That is, the probability of a conjunction of 2 events is much less than the probability of, it cannot be higher than the probability of a singular event. So, if I am talking about 2 scenarios, let us say I have a description here. Linda is 31 years old, single and outspoken, very bright. She is majored in philosophy. As a student, she was deeply concerned with issues of discrimination and social justice. Also, she participated in anti-nuclear demonstrations. Now, what is the likelihood of the following 2 alternatives? And there are 2 examples. Linda is a bank teller, and second is Linda is a bank teller who is active in a feminist movement. Now, the fact is, a lot of people basically mistook this thing. The technical thing is here that because feminist bank tellers are basically a subgroup of all bank tellers, the probability of feminist bank teller should be much lesser as compared to the probability of Linda being a bank teller. Okay. So, a lot of people would make this kind of a mistake. The second, a different kind of heuristic that also operates while people are doing inductive reasoning is the law of large numbers. What is the law of large numbers? The idea is that is, the larger the number of individuals that are randomly drawn from a population, the more representative the resulting group will be of the entire population. Suppose I am drawing a sample of 5 people. How likely is it that these 5 people represent the whole population? Suppose I am drawing a sample of 1000 people. How likely is that this 100 people will represent the more population? So, obviously, you will assume that the second picking will have more representative, will be more representative of the entire population. So, let us have this example again borrowed from Goldstein. A certain town is served by 2 hospitals. In the larger hospital, about 40 babies are born each day, and in the smaller hospital, around 50 babies are born each day. As you know, about 50% of all babies are boys. However, the exact percentage of boys and girls must be varying from day to day. Sometimes it might be the fact that higher than 50% of them are boys, or sometimes lower than 50% are boys. For a period of 1 year, both of these hospitals, a large hospital where 45 babies are born every day, and a small hospital that 15 babies are born each day, recorded the days in which more than 60% of the babies were boys. Which hospital do you think would have recorded more such days? So, the larger hospital or the smaller hospital, or both would have done about the same. Now, what happens here is, when Kahneman and Tversky basically presented this, 22% of people picked larger hospital, and 56% of the people picked that the rates will be about the same. Now, what is happening with the second group is that they are assuming that there will be no difference, because in the larger run, in the long run, and the birth rate for both the hospitals would be almost identical, which should will not be really very different, because it's being observed for up to 1 year. But the correct answer is that there would be more number of days with 60% more male births in the smaller hospital. Okay. Why is that? Because the fact is, again, there's a sample size is very small there, but people, what they are doing is, because they are looking at the global sample size, they are looking at 1 year, and they are saying in 1 year time both the birth rates in both the hospitals should be identical. Another bias that I can talk about is referred to as the confirmation bias. That is our tendency to selectively look for information that confirms to our hypothesis and overlook information that argues against it. You look around yourself, you see how you read news, or how you listen to news, or how you evaluate what people are telling you. You will find that a lot of times we are much more likely to believe, we are much more ready to believe what is consistent with our points of view as compared to what is not consistent with our points of view. Let us say, Watson basically did this very interesting task, and he presented the participants with following instructions. I am going to give you a bit of an experimental demonstration. So what happened was, the instructions were like, you will be given 3 numbers which conform to a simple rule that I have in mind. Your aim is to discover this rule by writing down sets of 3 numbers together with your reasons for your choice of them. So the idea is, Watson will give you 3 numbers, and then people will basically be writing 3 numbers which should test the rule which Watson has in mind. After you have written down each set, I shall tell you whether your numbers conform to the rule or not. When you feel highly confident that you have discovered the rule, you are to write down the rule and tell me about it. So this is the instruction that Watson gave. After the instructions were presented, Watson gave the first set of numbers, which were 2, 4 and 6. The participants then began creating their own sets of 3 numbers, and they started receiving feedback from Watson. Watson told participants only whether the numbers proposed fit their rule. The participants did not find what their rule was correct until they felt confident enough actually to announce the rule. The most common initial hypothesis was increasing intervals of 2, 2 plus 2, 4 plus 2, 6. Because the actual rule was 3 numbers increasing order of magnitude, the rule increasing intervals of 2 is incorrect, even though it kind of fits the overall rule, even though it kind of creates the sequences that satisfy Watson's rule. So they were not able to test it. Now the secret to determining the correct rule is to try and create a sequence that does not satisfy the rule. So if somebody comes up with a sequence 2, 1 and 5 or something like that, that is what will test the rule. So thus determining that the sequence 2, 4, 5 is correct allows us to reject our initial hypothesis, and it allows us to make our new hypothesis. Okay. So there were few participants whose rule was correct in their first guess, followed by a strategy, and basically what they did was they followed a strategy by testing a number of hypotheses themselves before announcing their rule by creating sequences that were designed to disconfirm their current hypothesis. So the idea was, what these people were doing is they saw these three numbers that Watson was given, and they came up with an hypothesis. Then they started coming up with numbers which disconfirmed their hypothesis, and it's kept doing it again and again till they were very confident that they have figured out the correct hypothesis. In contrast, participants who could not guess the correct rule on their first try, they tended to keep creating hypotheses that confirm their current sequences that confirm their current hypothesis. So they kept creating numbers which kind of fitted with what they were thinking. Now this confirmation bias, this is basically what confirmation bias actually works like. So the confirmation bias kind of acts like a pair of blinders, it's just like you put 2 things on your eyes, and what we do is you seeing the world according to the rules you think are correct or we think are correct, and so that we are never dissuaded from this view, because we seek out only evidence that confirms this rule. If you have a particular kind of a opinion about somebody, if you have a particular kind of an opinion about a particular class, what you tend to do is you only look at those aspects of the behavior of this person that fit what you initially thought. You kind of tend to very conveniently ignore everything else that does not fit your hypothesis, and this in sense is the problem with your reasoning, and this is basically what confirmation bias is all about. And this confirmation bias is so strong that it can actually affect people's reasoning by causing them to ignore sometimes very relevant information as well. So, Lord and co-workers, they wanted to test this out, and they basically demonstrated this in an experiment that tested how people's attitudes are affected by exposure to evidence that contradicts those attitudes. So, sometimes people are not able to change their attitudes even in presence of particular kinds of evidence. Let us see. By means of a questionnaire, Lord identified one group of participants who were in favor of capital punishment and another group of participants that were not in favor of capital punishment. Each participant was then presented with descriptions of research studies on capital punishment, showing either that capital punishment was acting as a deterrent or not. So, they were presenting each participant with studies. Some studies showed that it was acting as a deterrent, some studies showed that it was not acting as a deterrent. When participants were reacting to these studies, their responses reflected the attitudes they initially had, at the beginning of the experiment. For example, an article representing the evidence that supported the deterrence of the punishment was rated as convincing by proponents of capital punishment and unconvincing by those that were against it. Here you see the working of how the confirmation bias is going. So, people are kind of finding things that are they think that anything that confirms with my perspective is more convincing evidence, and anything that does not confirm with my perspective is less convincing evidence. And you will see this operating all the time, all around you, and in the way people talk and create arguments. So, this is all about inductive reasoning from my side today. We have one more lecture to go from reasoning and decision making, and we will talk about that in the next lecture.